Alright, so we won't be looking at chain rule today. Chain rule talks about when one function is inside another. Now I'm going to use the trig values to explain chain rule. Remember, we said something from our previous class that sine x equals to cos x. That is the differential value d dx for sine x. Why is that? The first thing we understand about chain rule is that if you differentiate sine, you're going to get cos. Now, when you differentiate sine, keep the angle the way it is, do not touch it. X. Now, if you differentiate x, you get what? Times 1. And if you check, this doesn't make any difference. Cos x is times 1 is still cos x. Now, but for what I'm about to explain here, I'm going to use u. Then we have sine u equals to what? Cos u times u prime. Now, why am I doing this? Here, x is 1. But sometimes, x could be anything other than 1. It could be x squared. You understand? The angles could be other than just x. Hence, the differential value will take precedence, will be effective. So, the same thing goes to cos u. It's going to give us what? Negative sine u times u prime. The same thing. If you go to tan u, you get the same thing, sec squared u times u prime. You do the same thing. If you go to cot u, you get the same thing. Remember, I started with a c, so you have a negative, but the same tan. Remember in my previous video, I said tan should give you the same as cot. But remember, we have the what's connecting them? Tan, sec, cotan, cosec squared, cosec squared u times u prime. Then we go to the next one, sec u. Sec, remember, gives you itself. Sec u and tan u. There with what? U prime. This is for chain rule. You differentiate this, keep the angles the same way. Differentiate cos, I kept the u. Then I differentiate u, that's u prime. That's what we pretty much will be doing. Cosec u will give us what? Negative, starting with c, negative cosec u, then what? Cot u times u prime. This is what this will give us for the differential value. Remember this information. So they will give you all this. If you differentiate this, differentiate cosec, you get what? Cosec cotan. Keep your angles the same way. Then differentiate u, you get u prime. So it takes the same event in all of them. What this means is that if sine x equals cos x for differential value, what if I say sine x squared? Now I will have what? Differentiate sine, I'll get what? Cos. Keep my angle the same way, x squared. I didn't touch it. Now if I differentiate x squared, I'll get what? 2x. Now you see that I need this u prime. 2x. Because here it was just, if I differentiate x, I'll get what? 1. 1 times cos x is still cos x, no difference. But in this case now, my final answer was 2x cos x squared. And you see, so it's important. This u is a function of x. It's a function of x in this expression. So it's important. Alright, this is a general question. We have a function inside another function. This function is inside of this. So you want to generally start differentiating from outside to the inside. So it's just like saying we have a function of f of g of x. Now, how do you differentiate this? From the differential value was f prime of g of x times the differential what you have inside, g prime of x. That's what you do. Then you now differentiate the x too, but in this case, x is wrong. We didn't use, if I use u, it will be what? U, then what? U prime. If I was to use u, it will be f of g of u, then differentiate f prime of g of u times g prime of u times u prime. But if it were x, because if I differentiate x, I will get 1. If I differentiate x, I will get 1. So I won't need to put anything here. So let's get down to this question using this same approach. So the simple idea is that I'm differentiating this first. So let's go. What we have is differentiate sign. What do you get? You get cos. Keep the angle the same way. Do not touch your angle. Q times, now differentiate what you have inside. What we have inside, 3x squared. Now this is our answer. 3x squared cos x cubed. And that's our answer. The differential value for this expression. That's it. We take the next one. We have another question there. This is the value. So we have ddx of sec squared into bracket 2x squared plus x raised to power 4. We have this question. So in the same vein, the first thing we want to do is differentiate sec. If you differentiate sec, what are we going to get? We're going to get what? Sec, keep your angle the same way. 2x squared plus x raised to power 4. Remember, sec tan. Tan, keep the same angle. 2x squared plus x raised to power 4. Now, we have done that. So differentiated sec. Times, now differentiate what we have inside. Differentiate the function inside. This will give us what? 4x. 4x plus 4x raised to power 3. Now I've done that. So this is the differential value for this. We can keep our answer at this way, but we can choose to start with this one and rearrange it. We could choose to write 4x plus 4x cubed multiply sec into bracket 2x squared plus x raised to the power 4 tan same keep your angle 2x squared plus x raised to the power 4. This is also our answer. It's the same. So this is correct. Okay, yeah, this is a bit tougher than some other examples that we have attended to, but still it's very easy. You just walk away from the outside to the inside in terms of differentiating this. You differentiate. But first thing, you want to bring this power. Once you see a power, you take it out. Take it out. Let it appear like a power ring. So the first thing we want to do is arrange this. We keep it as sine into tan into cos x squared. Then we'll put the rest brackets all raised to power 3. Now we start differentiating. Remember, this is d dx. So we'll start differentiating. If we're going to differentiate this, we'll bring our 3 out. We're going to get what? 3 into brackets sine tan. Open your bracket, you write your cos and cos x squared. All raised to power 2. It drops down to 2, just like differentiating x cubed. It drops down to 2. Now the next one, multiplying. Once you multiply, you divide, you differentiate. The first item we have is sine. Differentiate sine, what do we get? We get cos. Cos. Remember, once you differentiate sine, write every other and write every other entries you have inside of sine. What do we have? We have what? Tan. Open our bracket, we have a cos and we have x squared. Okay, bracket everything. Now this is everything we have. Now the next thing, we differentiated sine. We got cos. So we write everything that was there initially inside of it. Now differentiate tan. When we differentiate tan, what is tan? Tan gives us what? Sec squared. Now remember, write everything under it. What do we have under tan? Inside tan, we have cos x squared. So we are going to write it cos x squared. Now, what is next? Multiply by what? Now, differentiate cos. Differentiate cos, what do we get? We get negative sine. What do we have inside of cos? X squared. Write it. Don't touch it. Write it x squared. Done that. Now, the next one to get is what? Sine x squared. Now, differentiate x squared. What do we get? We get 2x. And now, this is our answer. So, we can connect the negative 2x and the 3. So, it's going to give us negative 6x into bracket. You can write every other thing now. Sine, open bracket, tan, open your bracket, cos and x squared, the angle, all raised to the power 2 times, we have cos, you could put the brackets here, but all they are all multiplying each other, times, open bracket, cos x squared times sec squared, open the brackets, cos x squared times sine. We've already taken the negative out, so we're writing what? Let me write it here. Sine into bracket x squared. And these are our final answer. The 2 have already multiplied with 3 and negative to give us 6. So this is how you differentiate the question as such. Take it one after